This video is an overview of road surfacing. The surfacing is the top surface of the road. It waterproofs the pavement and provides the surface for the vehicles to run on. The surfacing may also be known as the wearing course, surface course, or top course. All of these phrases are used on site and in documents, but they mean the same thing, the top surface of a sealed road. There are a variety of requirements for the road surface. The surface has to be strong enough to resist the loadings from the road. It needs to be able to transfer the wheel loads down to the base course without cracking or breaking up. It also needs to be able to transfer the shear forces caused by turning, braking, and acceleration to the base course without unraveling. This means there needs to be good adhesion between the surfacing and the base course layer. Surfacing provides a waterproof layer to prevent surface water getting into the base course. Water in the base course will result in the loss of strength of the base course. Surfacing also provides a barrier between the base course and the heating, cooling, drying, and wetting caused by exposure to weather that can cause the base course aggregate materials to deteriorate over time. The surfacing material itself needs to be especially resilient to weathering, as it is part of the road that is most exposed to weather. It is also the part of the road that experiences the wheel loads, so it needs to be resilient to abrasion and crushing from the constant contact with vehicles. The aggregate can be crushed if it is not strong enough. Crushed aggregate particles are no longer able to provide support for vehicles. Abrasion is especially an issue with chip seals, as the chip surface can become polished and not provide adequate grip for vehicle tyres. The surface also needs to be smooth to provide a comfortable ride for road users. A smooth surface also reduces rolling resistance, so saving fuel costs and vehicle wear and tear. However, the surface also needs to provide a texture that allows tyres to grip the road in wet and dry conditions. Skid resistance is an important safety feature of the road surface. The surface has to provide grip for vehicles when they are turning, braking, and accelerating, so the vehicle does not skid out of control. However, the surface also needs to provide minimal resistance to the tyres to minimize the fuel costs of vehicles using the road. Water on the road surface reduces the contact between the vehicle and the road, increasing the risk of vehicles aquaplaning in wet weather. The surfacing needs to be designed to be able to maintain contact between tyres and the road in all rain conditions. This means the road is designed to drain the water off the road using cambers or porous layers and have surfaces that remain above the surface water level. We will see how chip seal surfaces are designed so that the water drains in the low parts of the chip, but the chip still protrudes out of the water to provide grip for the vehicle tyres. Visibility is another important issue on the road. The surfacing needs to minimize glare and reflection from the road surface. The surface markings also need to be visible in all conditions to allow drivers to stay within their lanes. The surface also needs to minimize spray generation. Excess spray coming up off the road can hinder vision for the following vehicles and those going the other way. The main way this is done is by reducing the water on the road using good drainage. The coarse surface textures can also reduce the spray produced from the road. Noise from the road also needs to be considered. Coarser surfaces cause more road noise, which can be a problem in urban areas close to high-speed or busy roads. At speeds above 50 km an hour, the main noise from cars is the noise of the tyres on the road, as opposed to engine noise. Construction cost is another important consideration. A road surface covers a large area and requires significant quantities of materials, which need to be able to be procured at reasonable prices. The road also needs to be able to be constructed in reasonable time with minimal resources to reduce cost, so the surfacing methodology needs to be as efficient as possible. Basically, the surfacing has to provide the required performance at a reasonable cost. The cost also includes the consideration of the costs of maintaining the surface. Maintenance of the surface to fix defects or replacement of the surface costs money and causes disturbance to road users. so the time periods between required maintenance activities needs to be maximised. Cracks or other defects in the surface can result in water draining into the base course layer, so reducing its strength and potentially resulting in other damage. The loss of surfacing also removes some protection to the base course surface, so increasing the risk of the surface unravelling. It also needs to be remembered that the cost of replacing a road surface also includes the costs related to reinstating road markings and other features on the road. Surfacing typically consists of two main components, the aggregate and the binder. The aggregate is usually uniformly graded rock particles made from high quality rock. Uniformly graded means the aggregate particles are all about the same size. High quality rock is very hard without any defects or anything like that. It is also very expensive as it is not always available. When used for chip sealing, it is called chip. The aggregate needs to carry the road loadings directly, and so it needs to be made from rock material that will not crush or abrade under the traffic loads. The aggregate only resists and transfers the road loads. It is the base course that provides the structural support for the vehicles, therefore there needs to be a very strong bond between the aggregate and the base course. This is provided by the binder. The binder is like the adhesive for the aggregate. It holds the aggregate in place and allows the road loads to be transferred to the pavement layers. The binder is usually made of a bitumen-based material. Bitumen is a solid component of crude oil and is produced during the oil distillation process. It is a black substance, which is a sticky viscous liquid when heated to 120 to 180 degrees centigrade, but hard and solid at road temperature. Viscosity is the measure of a liquid's resistance to flow. Bitumen has a high viscosity even when heated, which means it flows very slowly like honey, as opposed to quickly like water. It is very impermeable, which means it will not let water flow through it, which makes it ideal as an waterproofing material. However, being a hydrocarbon like petrol, it will burn at temperatures over about 230 degrees centigrade. So the aggregate carries and transfers the traffic loads to the base course, while the binder holds the aggregate in place and waterproofs the pavement, as well as adhering the surface to the base course layer underneath. There are two main types of surfacing commonly used for flexible pavements, namely chip seal and asphaltic concrete. There are variations on these materials, but we will just look at the most common surfacings. Chip seal involves embedding chip in a layer of bitumen. The chip is the aggregate and provides contact with the vehicles, while the bitumen binder holds the chip in place. In Australia, a chip seal is called a sprayed seal, while other countries call it a surface dressing. In the Austroads manuals, chip seals are referred to as sprayed seals. Asphaltic concrete, or AC for short, has individual aggregate particles encased in a layer of hot bitumen binder. It may also be known as asphalt, AC, or hot mix. The AC needs to be prepared at a processing plant, so the mix needs to be transported from the processing plant to the road site while still remaining hot.